The conic that we're working on now is the hyperbola. The hyperbola looks like a parabola. It's going to surround a focus, but you're going to have two curves instead of one curve. So looking at a hyperbola, let's go through some of the parts. So we have two types of hyperbolas. We have a horizontal hyperbola, and on the horizontal hyperbola, the curves are going to go this direction. And I call this a Hurley because it looks like the surfer curve. So my nickname, you know, I like the nicknames, is going to be Hurley for that hyperbola, and it's a horizontal hyperbola. The vertical hyperbola is going to be a curve that moves up and a curve that moves down. My nickname for that one is going to be Happy Sad. All right, so now what we're going to do is, how do we know the equation is a hyperbola and not an ellipse? How we know that is, do you notice there is a subtraction instead of an add? So that's going to be critical. You'll notice that the a squared and b squared are in the same order. This is because a squared can now be smaller than b squared. So it is different than the ellipse. You'll notice, how do you know then that it is a horizontal? How you know it's a horizontal is the x squared is going to be positive. That will give you this horizontal one. Now, if the y squared is positive, so here's the y squared, if it's the positive ratio, then y squared, it will be horizontal. So that's how you tell the difference between the two. Now, looking at the two graphs, I just want you to notice that if it's a horizontal, you're still going to have vertices on these curves, and we're going to call this A and the opposite of A. From the center, you'll still count right A and left A. If it's a vertical hyperbola, then you will count from the center up A and down A. So you still have vertices. Within the curve, you're going to have a focus. Here's the focus here. The curve's going to wrap around the focus, and we're going to call those C's. Here's the focus here, opposite of C. So a hyperbola is going to have foci, which means there's more than one focus. All right, then from there, you're going to see, how do we know how wide to make the curves? Well, we're going to know how wide to make the happy sad or the Hurley by drawing this rectangle in which asymptotes are going to move through the rectangle. All of this asymptote and the rectangle, they're not part of the graph. They're just helping me to graph a graph that's the most accurate. So we're going to go through how to graph in just a moment. Before we do that, how do we find the C's? To find the foci, you're going to do a squared plus b squared equals c squared. So notice there's an add. The ellipse is a squared subtract b squared. So there is a difference between the two. What about these asymptotes? Here are the equations of the asymptotes. And notice it's a plus or minus because we have two lines. We have a positive slope line and a negative slope line. So this stands for two of those asymptotes. Basically, though, we're just drawing a line. The b over a or the a over b is simply the slope. So let's go through and graph some hyperbolas. So the first thing we're going to do is determine that it's a hyperbola. And I know it's a hyperbola because of the subtraction in the center. Now I have to determine, is it a Hurley, which is a horizontal hyperbola, or is it a happy sad? Well, this, because the y squared comes first, this is going to be a happy sad graph, which means we're going to have a curve going up and a curve going down. Now looking at this, y squared, the formula is y squared over a squared subtract x squared over b squared is equal to 1. So the a squared is equal to 9 and the b squared is equal to 4. So 9 is under the y squared and 4 is under the x squared. How do I find a and b? Simply take the square root. So the square root of 9 is 3 and b, the square root of 4, is 2. So now we're going to go ahead and graph the center of the hyperbola. Because there's no HK, the center is going to be at 0, 0. From the center, we're going to graph the vertices of the curve. And because this is a happy sad, our A's are going to go up, 1, 2, 3. So there's A, and down, 1, 2, 3. Now, I didn't tell you about the B's, but the B's are going to go in the other direction. So from the center, I'd like you to count right 1, 2, and left 1, 2. And if I go too fast, you can go ahead and stop the video, catch up, push play again. So you're going to draw a rectangle. The rectangle isn't really part of the graph, but it's going to help me draw an accurate hyperbola. So there's the rectangle, and through the rectangle, I like to always think of X marks the spot. So you're going to have an X going through the corners of the rectangle. So if I wanted to sketch in the asymptotes, you would go through the middle and through the corners of the graph. Now, I was off a little on that one. If you wanted the equation of the line, then what you would do for the equation of the line is you would do y equals, and you're going to do rise over run. So from the middle, it looks like we're going up to A and over to B. So it would be y equals A over B. And then the second line would be y equals the opposite of A over B because we're going in the other direction. So what would the asymptotes be? It says find the asymptotes. Well, it would just be y equals 3 over 2. Y equals negative 3 over 2. So y equals plus or minus, oh, and this is going to be x, of course. Y equals plus or minus 3 over 2x. And that's the equation of the asymptotes. Now, the vertices are your A's. So let's look at the coordinates of our A's. 0, up 3, 0, down 3. So 0 and plus or minus 3. And you can write that as 2 ordered pairs if you had wanted to. Now we're ready to sketch our graph. And the graph is going to start at the vertice, and you're going to approach the asymptote, but you're not supposed to cross it. So you approach the asymptotes and start at the vertice, approach your asymptotes, and that is your hyperbola. So just the blue is the actual graph. Now, how do we find the foci? The foci, I'll put that in, let's do purple. So foci is going to be in purple. The foci should land inside of it's going to be on the same transversal axis as the A's and the opposite of A's, but it should be inside the curves. So the formula is c squared equals a squared, unlike the ellipse, plus b squared. Now we're going to go ahead and just plug in a squared, b squared. So c squared equals 9 plus 4. C squared equals 13. So c is equal to the square root of 13. The square root of 13 is close to the square root of 16, so it means it's a little bit less than 4. So you would count 1, 2, 3, and a little bit less than 4, and there's your C's. 1, 2, 3, and a little bit less than 4, and there's your opposite of C. Those are your foci. If I wanted to write the foci as an ordered pair, the foci, there's 2 of them, would be 0 because we did not go left or right, and then it would be plus or minus root 13. Okay, pretty simple. That's how you graph a hyperbola. So example 2, we're going to be writing an equation of a hyperbola with the given clues. So what we might want to do is just graph the clues. So the foci is 0 down to, that's your C, and 0 up to, which is your C. C opposite of C. There we go. And the vertices are at 0, -1. So that's your A, or opposite of A, and 0, +1. So if I were going to do just a quick sketch of what this looks like, this is going to be a happy and a sad hyperbola. So we are going to write the equation. The equation is going to have the y come first. So it would be y subtract k squared. Here's a good reminder. K's always go with y's. Over a squared. Subtract. And then you have x subtract h. H's always go with x's, squared, over b squared is equal to 1. So I can write this equation, but there's some things that I need to find. I need to find the k, I need to find the h, I need to find the a squared and the b squared. So some of these things I already have, but some of these things I do not have. So let's figure out what I have and what I still need. So starting with a squared. So from the center, which looks like the center is at 0, 0. So the HK is going to be 0, 0. And from the center, A looks like it's 1, because from the middle, we counted up 1 and down 1. So A is going to equal 1. If I take A and square it, 1 times 1 is also 1. So your A and A squared are 1. Now let's figure out what our C's are, because I didn't give you B's. So the C's, well, from the center, I went up 2 and down 2. So it looks like C is 2 and C squared is 4. Now I can figure out my B's by using C squared equals A squared plus B squared. It's the Pythagorean theorem, but it's really not, because we're not using right triangles. So, but if you think of Pythagorean to go with hyperbolas, you'll remember the formula. C squared happened to be 4. So 4 is equal to 1 plus B squared. So now I can subtract the 1, and B squared is equal to 3. Now here's the deal. I know that B is equal to the square root of 3, but I'm not going to use it. I'm only going to use the B squared and the A squared and the H and the K. So H and K are 0, 0, so I don't have to worry about those. So now I am ready to write the equation. Here I go. Start with the Y. So it would be Y subtract 0 squared. Now, y subtract 0 squared is the same thing as y squared. So let's just write it as y squared. Y squared over a squared. Well, a squared is 1 technically you could just write it as y squared because it's the same thing. Subtract. My h is also 0, so I'll just put x squared over, and then I need to know what b squared is. B squared is right here. It was 3 equals 1. And there's my equation of a hyperbola. And I keep doing happy sads. I hope the next example is going to be a Hurley. And yay, example 3 is a Hurley. And I know it's a Hurley because the x is squared and it's positive, and the y squared comes next, and the y squared is negative. See this, the subtraction in the middle? And because of that subtraction, I know it's not a circle, I know it's not an ellipse, I know it has to be a hyperbola for the conic. Now the center is HK. So for the center, we're going to do HK, and so positive 2, because h's go with x's. And if it's plus 1, that's a minus 1. So negative 1 for the k. Let's graph the center. Go right 2 and down 1. That's the middle of my graph. The hyperbola is going to open to the left and it's going to open to the right. It is a surfer parabola. Hurley. Now, the vertices. So let's talk about the a squared and the b squared. The a squared is always this first number on Hurley's. So 16, which means a is equal to 4. Now, the c squared is going to be, let's do the b squared first. B squared is 9, which means b is equal to 3. How do you find the foci? C squared equals a squared plus b squared. So c squared is equal to 16 plus 9. Basically, you add these two numbers on the bottom of those fractions together. So c squared is equal to 25. The square root of 25 is 5. So c is 5. The foci are c units to the right and left of the center. So from the center, I want you to count right 1, 2, 3, 4, 5. There's c. And left 1, 2, 3, 4, 5. There's the opposite of c. Okay, what about the vertices? From the center, let's find the vertices. We're going to count to the left and right 4 units from the middle. So 1, 2, 3, 4. There's A. Whew, good. The C is going to be inside the curve. And then left 1, 2, 3, 4. If it isn't, you did something wrong mathematically. Now we are ready, except for why don't we draw the box so we can have a really nice graph. So from the center, count up B units. 1, 2, 3, there's B, and 1, 2, 3, the opposite of B. Now we're just going to sketch in this imaginary rectangle. This rectangle just helps me to make a beautiful graph. So there's the rectangle. Now start from the center and go through the corners of the graph. Let's go through the corners of the imaginary rectangle. So we'll go through the corners of the imaginary rectangle. Now we are ready to go. Let's draw our Hurley symbol. So we start at the vertice, which is the A, and we're going to curve off in this direction, off to the right. Always start your curve at the vertice, and then we're going to curve off. Oops, I don't need to make that dotted. Solid. Curve off to the right. And Hurley there's my graph. You can see that my focuses are inside. Now let's talk about eccentricity. Eccentricity is the curvature of the graph. It should be greater than 1 for the hyperbola. So ellipses, eccentricity is between 0 and 1. Ellipses, it breaks, a circle is exactly 0. And then we look at how the curve changes. So this is going to curve out to C over A. So the eccentricity is going to equal C, which is 5, over A, which is 4. It should always be greater than 1. The asymptotes. So if they wanted the equation of these diagonal lines, up here tells you how you can write the equation. Basically, though, we're still looking at rise over run. So that's your B over A or A over B. But we have to shift it from 0, 0 to starting it from HK. So that's why it's just a little bit different. So because the parabola opens left or right, we're going to use the first formula. So the formula for the asymptote is y subtract k equals, and you can do plus or minus, which is going to be the positive line and the negative line all in one equation. And it would be B over A. And this makes sense. Look at this line. It's rise B, run A. Rise B, run A. And that's going to put you on that diagonal line. So B over A is the slope. And then times X subtract H. So Y subtract K would be Y subtract. And then K, where is my HK? Here's my H. And here's my K. So it'd be Y subtract negative 1. So Y plus 1 is equal to plus or minus B over A. So B happens to be 3 and A happens to be 4. So 3 over 4 times X subtract H, and H is 2. You should recognize that this equation is in point slope form. It's perfectly fine. Leave it in point slope. If the multiple choice wanted me to change it, then I could solve for y. But point slope is perfectly fine with me. So there's the asymptote. If you needed the values for the vertices, so the vertices are going to be where this A is, here and here. So you would have to take your center and then you would have to add 4 and subtract 4. So this is going to be right 2 plus 4, which is 6. So vertices are where your A's are. So you would go right 6 and down 1. You would also go left. So start from the middle and you would take 2 and then subtract 4. So 2 subtract 4 is negative 2. Negative 2, and then you would still be down 1. So here are your vertices, which are your A's. So those are your A's, and I can highlight those in the purple. Here's your A's. Those are your vertices, and here are your vertices. Very good. I think that's everything. So we have a couple of problems left. Let's go through and see how these work. Writing the equation of a hyperbola. So the foci are your C's, and your C's are 4, 0, and 4, 10. I like to graph it so I can see what type of hyperbola I'm looking at. So go right 4 and up 0. That's your C. And then go right 4 and up 10. Okay, so you can see that this is going to have to be a happy sad because of where those foci are. And the A's are going to wrap around the foci. So you're going to have a vertical hyperbola. It says that the vertices are 4, 1. So let's graph the vertices. right 4 and up 1. So there's your A, which is going to be your sad. And then 4, 9. And then here's your opposite of A, which I don't know if that really works. It's not really opposite, but there's your A, and it's going to open up. So there's your vertices or your A's. Let's try to figure out halfway in between the vertices so that we can figure out where the center is. So let's count to find the center of that graph. So we're here. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 from the A to A. So 1, 2, 3, 4. That is going to be the middle of your graph. So let's figure out what the HK is. So you would look at that one, and your HK is going to be right 4 and up 5. So the next thing we're going to do is figure out what the B's are. So from the center, the distance from the center to the foci is 1, 2, 3, 4, 5. So your C is 5. And so if C is equal to 5, then C squared is equal to 25. The A squared is the 4 because from the middle we're going up 4, down 4. So that's 4 squared, which is 16. And now we're going to find the B squared. So take 16, subtract it over to the other side. And that equals 9. And then square root. And so B is equal to, didn't mean to put B squared, I meant to put B. B is equal to 3. So from the center, we're going to count the B's, which is going to go right 1, 2, 3, and left in the opposite direction 1, 2, 3. So that's why I use the opposite. I just mean the opposite direction from the center. So now we want to make that lovely rectangle. Here's my beautiful rectangle so that I can graph this really great hyperbola. So the hyperbola is X marks the spot. So you're going to go through the corners from the center, through the corners from the center. And then you can sketch in your hyperbola, start at the vertice and move towards the asymptotes. And this one is happy. And this, oops, don't go from the foci, go from the vertex or your A's. All right, this graph curves at the vertice is at the A's and the foci is at the C's. So there you go. You've got your happy and you've got your sad, and there is your graph. So I didn't fill in. A was equal to 4 because it's the distance from the center up to the vertice and the center down to the vertice. So we know the graph opens up and down. The equation. So to write the equation of this graph, really easy. It's y minus, and the y comes first because it's a happy sad, and k's go with y's. So the k happened to be, here's h and here's k. So y subtract 5 quantity squared over, and then you've got a squared. So a was 4, so 4 squared is 16. Subtract, because it's a hyperbola, and then you would have x subtract 4 squared. Now, if this 4 were negative, then it would be minus a minus, which would be plus. Over, and then b squared. And we found b to be 3, so b squared is equal to 9. This equation in standard form is equal to 1. So there's your equation. So this is the end of our video. Make sure that you try the U-try on your own and the reflection all by yourself, and then talk to your group to see if you get the correct answer or at least the same answer as everybody else. Thanks. Have a great night.